Hello. Today we are going to start the discussion about design patterns, but actually, in this lecture, I'm not going to discuss about any design pattern, but to take the initiative about why we need these design patterns and so on. So first, we start about some things, general things about software development. When we are asked to develop a system for some office or industry or business, first we have to analyze the requirements of the business to identify what actually we need to do. So before starting any designing or development or whatever, like designing or implementation, first we need to understand the process of the business. So we have to do analysis first. So what is analysis? Actually, this is mainly try to understand the system requirements. System requirements. So first we have to understand what are the actual requirements for this business, how this business is working, how the process is working, and also this part, the understanding the actual requirements. This is the most difficult and time consuming activity or task, and we know that the success of the entire system will depend on the accuracy and success of this task, the analysis. So I'll share some of my experience, very recent experience. Some gem business owner, he asked me to help to develop a system for his workshop and his shop. So I went there, and actually, like, he had a system, but he felt some difficulty in maintaining the system with one software developer. So he needed some advice to actually build a more robust system for his business, because business has expanded for like about 10 years now since the first software installed in the business. So now there's a real big need to develop a good software system to manage everything. When I went there, actually I didn't know about the gym business and government policies, tax and everything. I didn't know anything. I just went there like to thinking about some simple system for some shop. That's what I thought. But when I went there, I realized that I had a lot to understand about this business, how the process is happening. So in that case, actually in a shop, customers or the people who are going to buy the things are the clients. But in that business, they treat the guide as the client, not the people who are buying, not the tourists. So they have to, in that system, they have to have a way to treat the guides in as the customers and giving them their commission and so many things related to the guides. And also, when we talk even though I didn't know, the taxation things is really big there. So actually, I had a lot to learn about taxing and tax policies from a retired tax officer from the tax department. So finally, first I thought like this work is something like 1 month work, but actually it seems we have to do it for nearly 1 year because of the nature of the business. So requirement analysis is that hard. Unfortunately, I had to stop that work in the middle because of this corona thing. I couldn't go there very often because of a lot of tourists are coming there. So hoping to resume it later time, but now I understand that actual requirement analysis part is so difficult than even uh, I thought at first. So this is very critical and very important part of software engineering, software development. So let's discuss why this is going to be so difficult. First, like when we are given a task, okay. So first we are giving a task. Task is given to us. This task is the like develop a system for Gemshop. That's a task. Then we have to identify what are the problems there, how to handle the inventory, how to handle the returns, how to handle the taxes, how to calculate the taxes, how to calculate the commissions and loyalty programs, like sort of things. So we have several problems regarding the how to handle accounts. That is one problem. This is called problem. There are a lot of problems. We are going to give the answers for those problems. We have to identify the problems, each and every problem. And also there are some other things called symptoms. Uh, symptoms. So when we are given a task, we have problems and symptoms, we can identify them. What are the problems? Problems are the like they are the things like there's a specific solution for that. We can easily understand what is the problem. We can see there's a solution for that. For example, like how to create a bill for some sale. That thing, that's a problem, and for the problem we can clearly see the answer for the problem. But when we have a symptom, that is kind of an unclear problem. Symptom is unclear. Actually we don't know how to give a specific solution for that, or sometimes we are unclear about the requirements of the symptom. So there is some unclearness. For example, I will give uh, from my experience. So uh, when I when I was working with that gem shop, one problem was like how to create a bill, how to generate a bill for a specific sale. So that's a problem. We can clearly answer that from like take the item, read the barcode, and then barcode will give all the information regarding that item, and then when we get the cash or we get the card payment and we finish the sale. That's a problem. There's a symptom. Symptom is when we have something like customization for a specific item. So that means like if there is a ring or something, the, the client can ask, okay, change this stone to another stone and give me the ring. In that case, even though they have a workshop, they can't do billing for the workshop because of some taxing problems. So alterations are done in a different way, like not showing that they have a workshop in their shop. So they registered as a buying and selling business, not something to do the alterations. So the symptom for us was how to handle that, how to when somebody asks to do some alterations, how do we generate the bill? So there is an alteration like item should be like, if let's say like the item is a ring, we have to separate the stone from the ring, and the stone should come to the uh, inventory back as an item, and some other item should be issued from the inventory, and some other cost should be added for the alteration, and everything should be calculated and should go for the bill. So there are like few different uh, processes should go on to handle that, and we had problems like how to actually handle that without violating the taxation and those things. So it was a symptom. We had to discuss a lot to find a specific solution to handle that kind of alteration. So they are symptoms. Symptoms are kind of unclear problems. And once we analyze the symptom further, we can find there are a set of other, like we can identify few problems under that. Problems are the things like we can directly give answers. So symptom, when we analyze that, we can break down it to problems. That's the idea about symptom. So in like software engineering, when we are given a task, we will get number of symptoms. That's why this analysis process is going to be so hard. Not only problems, we have symptoms. So there what we have to do is we have to further analyze the symptom and should break down it into problems. Problems are the things like we can see the specific solution for that. And when we like break down a symptom into problems, we can see that sometimes there are conflicts with so I will do like this. So we are analyzing the problem further, the symptom further. Then we can see, can break down this into few sub problems. Okay, let's say K1, K2, K3. Likewise, we have sub problems. So these sub problems sometimes they are conflicting. If K1 and K2 is seems to be similar, sometimes this K1 and K2 seems to be similar problems. So then what we have to do, like we have to further discuss about these two things and remove one, because by giving solution for these two things, actually it is like doing the same thing. So we have to remove one because these two are similar. We have to identify conflicting problems then, and then remove the similar ones. And also we can see that some kind of amalgamation. Amalgamation means, let's say like this K3 problem, this problem, to solve this problem, it has two requirements. Let's say this problem has two requirements, R1 and R2, two requirements. In that way, we have to further decompose this thing in a way that we address one requirement when we solve one problem. So we have to decompose the problems in a way that solving one problem means satisfying one requirement. So when we see something like this, there are two requirements for this problem, that is called amalgamation. We have to further decompose this and make it in a way that we address one requirement by solving one problem. So when there are no conflicts and no amalgamation, this process is clear or correct. Synthum is break down into a set of subproblems, and they are not amalgamated, they are not conflicted. Okay, this is the first thing we have to do. When we are given a task, we have to identify the problems. Okay, problems we have like solving one problem means satisfying, addressing one requirement, and there are unclear problems. We have to further think about them, and we have to identify the problems, decompose it into sub problems like this, and then we have to make sure that there is no amalgamation and there is no conflict. So that means the task is decomposed into set of problems, and then our idea is like addressing the problems. We are giving the solutions for each and every problem, then we can come up with a solution for this task. Okay, and solving a task means finally the product is, what is that? That is a computerized system for us. Computerized system. When we solve or when we complete the task, it will give a computerized system. But to get this thing, we have to work on this process. And the person who is doing this thing is called system analyst. System analyst is the person, system analyst. System analyst is the person who is carrying out this task. So actually we have to understand now, system analyst should have the knowledge about the business domain and also about this software engineering. Then only he can do this work successfully. And then after that, he communicate this information to his development team, and the developers or the coding people, they know what to do actually. Otherwise, we will have to face many troubles. Okay. So I think now you have quite a good understanding about this analysis thing actually. Then let's discuss about something like software design. What is software design? Software design. Actually, the meaning of software design is to provide the best abstract solution to the problem. Not just the best solution, but best abstract solution, not a solid solution. Why do we need to do like abstract solution, not concrete? The reason is, when we provide the best abstract solution, that means we are giving the flexibility to implement this using in any object oriented or structured oriented or programming language or any platform. So our solution should not be restricted to any programming language, should not be restricted to some like hardware software requirements, specifications. So as much as possible, we have to provide an abstract solution. It should be implemented using any programming language. Should be able to use software engineering paradigms different. Likewise, we have to give some abstract solution rather than a concrete solution. So this process is going on like, first we are giving the SRS. SRS means system requirement specification. First we are given this system requirement specification. This is a document, SRS. And using this, what we have to do is, we have to outline the initial design. So we have to outline the initial design using the software or system requirement specification. So now we do this thing and we provide the initial design for validation. Validation means, first, like, we have to verify whether our design is actually addressing the requirements of the requested system. So when we do the validation, sometimes we feel, okay, this is not satisfying the requirements. So then we have to refine the solution to address the missing parts. The reason for not validation, like not passing this validation process, because we miss something. So then we have to refine it to address the missing parts, and then again give another design. So this is like send the design, I would say D, and then we redesign this, and this design is again validated. If it is not passing the validation, then we have to again refine. And when it is passing the validation, yes, then we are done. Done. So this is how this process is going on, the design process. First we are given the system requirement specification, and then we have to outline the initial design and then do the validation. We have to do this validation in few rounds and refine the system, and once it is passing all the requirements, like say like pass the validation, then we are done. Then we go for the further processes of the software engineering flow. Okay, I think now you have some understanding, good understanding about system analysis and problems and symptoms, and how to decompose the symptoms, and finally come up with a set of problems to address. And then once a requirement specification comes, when we do the design part like this. Okay, so in last lecture also we discussed about common design mistakes. Going for a concrete solution is a design mistake, and like not documenting is a design mistake. So we can find that, like going for concrete solutions, not documenting, and directly referring to the implementation thing. It's those are the things are the main mistakes or the common mistakes of software design. So we have to go with this process very seriously to avoid any mistakes in design part. So we have the SRS document, system requirement, and then the software design should be done by software analysts and software architects, and then the process should go for the implementation. And then this is validated, this is done, and this is the place where the developers do their job. So system requirement specification, this thing, specification is formal, like written in a formal language, not natural language, because the reason, like when we say something in natural language, that may be sometimes ambiguous. To avoid that ambiguity, we have to follow a formal language, mostly like, let's say, like mathematical statements. They are like, that's a definite statement, no double meanings there. But natural language, there may be some ambiguous feeling when we read it. So because of that, the SRS document is written in in a formal language. And then this design part, uh, this design part, there we have to like this is like a pictorial thing. Pictures are there in designs, class diagrams, and specific symbols and everything are there in the design part. The reason is again to make it non-ambiguous. Then it is very clear. So we have to identify like different classes. Like when we identify the classes, there are entity classes, bound classes, control classes, that sort of different classes. And for different classes, we have different kind of symbols. And that way, it is very clear documentation or design documentation will be created when we use some kind of a pictorial language rather than textual language. And also there we use the ideas about object-oriented concepts like inheritance, interactions, association, composition, likewise aggregation, depending on the requirement, like depending on the requirement, and also based on the experience of the person who is going to design this thing, he will use the required object-oriented concepts and come up with the design. So actually this part, the design part, it will heavily depend on the experience of the person who is doing that. So software architect or the system analyst, and they are actually well experienced people in software industry, not just a software engineer. They have number of years as a software engineer, developer, and then senior engineer, tech lead, and then they will go for the position like system analyst or software architect. Then they have a lot of experience. They have the knowledge about how to use the best, like the concepts in a way that we are coming up a best solution for the best design for this problem. So they are using all the object-oriented concepts we learned so far, like inheritance, composition, aggregation, and different things, and then come up with a kind of a diagram. And then do the validation, and then developers will work in this phase. And when we talk about this design phase, actually for a best design, the designer should not focus on a programming language. So not consider about any language at this phase. Design is fully open to be developed in any language. And also sometimes we have to like come up with a design like they use both object-oriented concepts and structure-oriented concepts. In that way, we have to have some kind of a bridge between those two paradigms. So that means there should be some interfaces to communicate through object-oriented implementations and structure-oriented implementations. So if that is needed, they are also designed at this phase. So we talked about a lot of information about this thing, but you will understand them more when you actually go for the industry and working there. Okay. And the other thing is, when we have our main topic is to discuss about design patterns now. So this is kind of a uh, our main topic actually is to discuss about design patterns, but so far we have discussed kind of a background to that, and we discuss uh, the about this design phase, how these things are happening, and the person who is doing the design use his knowledge and experience, and the success of this design phase is highly depending on person's experience and so on. Design patterns are kind of the thing, like people who are well experienced in software designing, they have come up with some ideas, some kind of guideline to use them when we have to design solutions for similar kind of problems. So that is called design patterns. Design patterns are actually not concrete thing. They are just guidelines to give solutions for commonly over and over occurring problems, repeatedly occurring problems. They are not rigid. They are very flexible, but just a guideline. Formally, you can write like this. Design patterns. Design patterns are reusable design components. For small scale problems, and this is a generic solution for a recurring problem. Generic solution for a recurring problem. These words are very important. Generic solution. This is not solid. This is very generic. And for a recurring problem means the problem has, like, this problem occurred previously, this problem is occurring now, and in future also this problem is occurring. That means we are designing, or we are developing systems for the real world use. University information system is something like people developed solutions for many years ago. Even now we develop solutions for university uh, information systems, and in future also we are using that. So the same problem, almost similar problem, will occur, and the solution is most of the time should be the like similar to each other. So that's why we say it's a recurring problem. And the generic solution means we are not saying, okay, this is the solution, this is the programming language, these are the classes. We don't say like that. This is generic solution. We have the flexibility to define and identify the classes in the way we want, and some kind of programming language according to our preference likewise. So that's about design patterns. And let's briefly discuss about a framework. It's a different topic, but I think it's worth to I understand the difference between frameworks and design patterns at this stage. Framework is a semi-implement reusable large-scale architecture. Design pattern is reusable design component for a small-scale problem, but this is a generic solution for a recurring problem. Nothing implemented. Framework is something semi-implemented. Like some classes are abstract classes are there, interfaces are there. Likewise, it is a semi-implemented uh, thing. We can reuse it for things over and over, but it's for large scale architecture. This is more solid than a design pattern. For example, I would say for a university information system, semi-implemented or the framework is something like classes are implemented, like partly implemented, packages are there, that sort of thing. But design pattern is just a guideline to design the solution. When we little bit talk about this generic solution thing, it is like we know that sorting a data set. Sorting a data set means we are using algorithm to sort a data set. Let's say like we are using an algorithm for sorting a data set. Algorithm is there, data set is there. When we use the data set, same data set, 3 times, 4 times, or 100 times, and using a particular sorting algorithms, we get the exactly same result for that 1 or 2 or 100 times. Exactly same result. It is kind of fixed thing. When we talk about a generic solution, that's like even though the data set kind of thing, like the problem is the same problem, solution or the design, the output of the solution, output is the design is going to be different. If we do the design for using same design pattern, let's say like the architect is given the same problem and asked to solve this problem, and he uses design patterns to do that. For the same problem, if he design, let's say, 100 times, there will be 100 different designs, even though he used same design pattern, same design patterns. But for a data set kind of thing, same data set, similar to same problem and same algorithm, like the design patterns used by the architecture, if those two things are same, solution is going to be same for 100 times. But for a design pattern kind of thing, it's generic, it's just a guideline. So 100 times with same problem and same set of design patterns, solutions or the designs will be 100 different designs. But still, all of them are following the guidelines of the design patterns. So that's the idea of generic solution, but recurring problem. So that's all about I wanted to discuss about the background of design patterns and some specific details of design patterns. And we will discuss about first design patterns in our next lecture. Okay, thank you.